Hi everyone. So I wanted to do another video to explain some important mathematical notation. This notation will be particularly important when we talk about preferences, where economists and mathematicians represent preferences typically as relations. All right, so let's get started. So first of all, recall two key facts about sets. The first is the order that the elements are listed in a set doesn't matter. So the set consisting of just A and B is the same set as the set consisting of B and A. Because remember, sets are the same when they contain the same elements. So this set right here contains two elements, namely A and B. This set right here also contains two elements, namely B and A. And for a similar reason, sets cannot contain multiple copies of the same element. So the set consisting of just A is really the same thing as the set where you try to write A down twice. In fact, this set consists of an element, namely A. This set also consists of an element, just A. So when we want the order in which we write down elements to matter, then we need to use something which is known as a tuple, or also known as an ordered pair. So we typically write ordered pairs using parentheses. Sometimes you'll see these triangle braces. So A, comma, B, comma, C inside of triangle braces typically means the same thing as A, comma, B, comma, C. Although the notation isn't completely settled, so you should always double check when you're reading some literature how they're using some notation. So a tuple is going to be a list of elements. Call it a sequence of elements. The order does matter. So we can talk about the first element of the tuple, or the first component of the tuple, and the second component, and so on. Tuples are always read from the left to the right. So A here is the first element of the tuple, B is the second element, and C is the last element, or the third element of the tuple. So with this notation in hand, we can see that the tuple consisting of A followed by B is not going to be the same tuple as that consisting of B followed by A. And also the tuple consisting of A followed by itself, so this is a tuple of length 2, is not going to be the same thing as a tuple of length 1, which is just the element A. Now, in order to form sets of tuples, we use the idea of a product of two sets. So if A and B are two sets, then A cross B is the set of all tuples where the first component comes from A and the second component comes from B. So for example, if A is equal to the set 1, 2, so this is my set A, and B is equal to the set A, B, C, so this is my set B, then A cross B is the set of these 6 tuples right here. So it's these 6 tuples. So 1 gets matched with A, 1 gets matched with B, and 1 gets matched with C. That's the first 3 tuples here. And then you do the same thing for 2. So 2 gets matched with A, 2 gets matched with B, and 2 gets matched with C. So you have the remaining 3 tuples right there. So A cross B is this set of tuples. So formally it's a set of tuples, but we can often visualize it by drawing a graph. So you draw all the elements of A on one side, all the elements of B on another side, and then you draw arrows from one side to the other when you match up elements. Now, a relation is just going to be a subset of tuples, so a subset of the cross product of x and y. That's generally what a relation is. So we want to identify we look at all the tuples relating elements from x and elements from y, and we want to identify some that might be particularly interesting, or we want to set aside or denote those, and that's what a relation is. So for example, these sets right here are all relations that relate elements of x with elements of y, where x is the set 1, 2, 3, and y is the set A, B, C. So if we have 1, 2, 3 here, this is the set x, and then we have A, B, C, this is going to be my set y. So this first set right here, this first relation, is going to be the tuple that matches 1 up with A, 1 up with C, and 2 up with B. So this relation is a set of tuples. It's not all the tuples of x cross y, but namely just these 3 tuples. So just to do another example to illustrate, let's look at this tuple, or this relation right here. Here, 1 is matched up with A, 2 is matched up with C, and 3 is matched up with B. So this is yet another relation. So here's one relation, here's another relation. Maybe you have a relation that just has one tuple. You just identify that one tuple that's important, so namely 1B. Notice this relation right here is actually just the entire set x cross y. So the whole product is itself a relation, and also trivially the empty set is a relation because it's a subset of x cross y. Now typically we are going to be talking about a relation on a set X. So you have a set of objects, and if I'm a decision maker thinking about those objects and I want to have a preference relation over that set of objects, I'm going to model my preference as a relation, so a subset of X cross X. So I look at the elements of X and I put them in a particular order. So here are some natural examples of relations. So for example, greater than, less than, and equal to. So there the set is the set of all natural numbers or the set of all real numbers. And we can think of less than or equal to as a relation, so it's a subset of, say, n cross n. So we look at the set of natural numbers and we relate. So less than or equal to, for example, it's going to be an infinite set, of course, but it's going to contain 0, 0, it's going to contain 0, 1, 0, 42, and so on. So this relation, less than or equals, is a collection of ordered pairs. It's a collection of pairs of numbers where the first number is less than or equal to the second number. Other examples of relations that naturally occur might be, think of the set of people, and then you talk about one person being to the right of or to the left of somebody else, or somebody standing behind somebody else, or standing in front of somebody else, or being below somebody else. An interesting one is in between. So this is actually a ternary relation. So it's a relation that connects 3 objects, so A, B, and C. And we will say they are related if B is in between A and C. So B is to the right of A and to the left of C. Other examples of relations on people is ancestral relations. So is mother of, is father of, is aunt of, is sister to, and so on. Transitive verbs is taller than, is shorter than, and so on. These are all examples of relations. Independence. This is a relationship between events. So you can say one event is independent of another event, and they are related in a particular way. For the computer scientist, a database is just a set of relations. That's all a database is. So you put objects into a database, and you identify relationships between the different objects in your database. And there are many, many others. The idea of a relation is really ubiquitous in mathematics. It's used all over mathematics and computer science and economics. So it's an important concept, and it's very important that you become comfortable with reasoning and talking about relations. So just to end with some notation or some ways of talking about relations. So a relation, remember, a relation on X is just going to be some subset of X cross X. So for example, if X is equal to A, B, C, D, then we might have a relation that looks like this. So it relates A with A, B points to A, C with D, A with C, and D with itself. So to visualize a relation on a single set X, what we're going to do is we're going to write down all the elements of X, and we can draw little circles around them. And then we can draw an arrow from one element to another element. So there's an arrow from B to A, and it's written BRA. So that signals the relationship that B is related to A. So B is on the left and A is on the right. So the tuple BA, or I'll sometimes say the pair BA, is an element of the relation. It's an element of the set of tuples that the relation picks out. So BA is in this relation. So BA is in R, and I'll denote that by writing BRA. And we might say things like B is R related to A, or B points to A. And I'm going to draw an arrow from B to A to signal that B is on the left-hand side and A is on the right-hand side. Okay, so to fill out the representation of this relation, we can look at A is related to A and D is related to D. So those are going to be self-looped, or what you might call reflexive arrows. Those are arrows that point back to themselves. And then finally, we have C is related to D and A is related to C. So A is related to C, C is related to D, and we have D is related to self, A is related to self, and B is related to A. So this picture right here is a visual representation of this relation. And we might also write down sort of facts about the relation. We might describe a relation just in terms of its facts. So A is related to A, B is related to A, C is related to D, A is related to C, and D is related to D. So this also completely describes this relation. All right, so this is just an introduction to how we're going to talk about relations. We'll also need to talk about different important properties of relations, but that will come later in another lecture.